Delivering great software, faster and safely. Those are the two main things employers expect from builders like us, but it's also what customers expect from all of us. Building serverless applications can help with the speed side of things. Why? Because with serverless, there are no more distractions looking after servers, no more worrying about scalability for infrastructure. All these things are taken care on our behalf by AWS. What this means is that you're freeing up engineering time so that you can do what really matters, shipping those services and features faster to your customers. But in order to deliver on this serverless promise of speed, we need the right tools. Who doesn't like achieving more with less code? Who doesn't like having everything you need in your local machine so that there are no interruptions when you're in the zone, authoring, testing, and debugging code? Have you ever been in the middle of a flight and thought, I know how to fix this bug, but realized you didn't have internet connectivity in order to have a crack at it and you needed it? Well, today I'm going to introduce you to the AWS Serverless Application Model, or SAM. SAM is going to provide answers to these questions, but more importantly, it'll make it easy for you to build serverless applications, making you a faster, more productive developer. But speed is only one side of the equation. How about safety? Just like in motorsports, in business we're trying to get more speed, but we don't want to compromise safety, do we? So in this case, I'm talking specifically about safety in deployments for developers. I'm sure no one watching this session has ever made a deployment nervously, not knowing if your code is going to break production or not. Am I right? Well, in this session, I'll also be showcasing features that will give you peace of mind when deploying serverless applications, reducing the blast radius, and automatically rolling back if your code doesn't work as expected. Speed and safety. By the end of this session, you'll know how to author, test, and debug serverless applications, all done with our internet, from the convenience of your next flight economy seat. But more importantly, you'll get access to the tools that you need in order to unlock the speed of serverless applications so that you can build anything serverless, anytime, anywhere. A couple of hours ago, you sat on your computer. If you're like me, you put on some jazz to get in the zone, and then you crank out some great code, some Lambda code, and you're ready to ship that to Lambda so that your customers can use it. But you're a great developer that knows manual deployments are bad. You want to use automation, and for that reason, you need to define your application as code. At AWS, we do this with AWS CloudFormation. CloudFormation is a service that allows you to create, manage, and update a collection of AWS resources in a controlled and predictable way. Now, the beauty of CloudFormation is that it's declarative, meaning that you define what the stack should look like, but you don't worry about how the changes are done or how they should be orchestrated. All of that is taken care on your behalf by CloudFormation. And because it is just infrastructure as code, it means you can chuck it in a repo and you get consistency over your deployments, traceability for resource configuration, you can share it around, iterate over it, etc. Now, you can certainly define serverless components using, such as AWS Lambda and API Gateway using CloudFormation. But as you start creating more complex, distributed serverless applications, you'll want the power of CloudFormation, but also the ability to write less code to define those serverless resources. This is exactly where the Serverless Application Model comes in, or SAM. SAM makes it easier for you to develop and manage serverless application. And it's also a squirrel, the only AWS service with a mascot. You can think of SAM as a higher level abstraction to CloudFormation, or maybe an extension or simplification of CloudFormation that's been optimized for serverless. You're still using CloudFormation in the background. When you upload your template, you upload it to CloudFormation, but you write it in SAM syntax, defining those serverless resources with a lot less code. Now, SAM supports anything that CloudFormation does. And I mentioned earlier that SAM makes it easy for you to define serverless applications. Let me show you how easy it is. This is a neat template with just 14 lines of code, and it contains everything that Sam needs in order to create and configure a RESTful API endpoint on Amazon API Gateway and an AWS Lambda function with all the wirings and permissions needed so that when your user hits the API with a HTTP request, it'll become the source event that triggers Lambda. This is going to be also, this template, our starting point for the demo that we'll be running in the first demo. Let's go through all the parts of this template. You start the template by defining in 2 lines that this template is written in a specific syntax, in this case, the SAM syntax, so that when you upload the template to CloudFormation, CloudFormation understands it and knows that it needs to transform it into a fully blown CloudFormation template. Now, to prove how much SAM is doing for you, let me show you how the transform template for this SAM template looks like. Look at all the code you didn't have to write. Isn't Sam a hard-working little squirrel? Now, after defining the syntax in the template, you define all of the resources that comprise your application in the same way that you would with CloudFormation templates. In this case, I am defining a single resource called calculator add. Given that this is a Lambda function, I need to give it the type AWS Serverless function. And then we define some configuration for that Lambda function, and in the form of properties. Now, some of those properties are mandatory, such as handler and runtime. I'm using Golang and version 1 for this function, for example. Other properties are optional, such as name and Lambda memory and IAM role that you want your Lambda function to assume, and the environment variables. So let's look at another property. This property is quite powerful, the event property, because it allows you to do 2 things at once. First, it defines the event source that is allowed to trigger my Lambda function, things like S3, Kinesis, DynamoDB. In this case, it is a HTTP GET request against my API Gateway endpoint. But secondly, Sam is smart enough to go out and create and manage that API Gateway endpoint as well, with the same lines of code. Of course, you could define API Gateway explicitly as a standalone resource within the SAM template by providing a Swagger file and a stage name. What we chose to have Sam make it easy for us with the event property. Another great thing about SAM is that it not only is it simplifying the syntax we use to define serverless apps, but also simplifying the deployment of those changes by providing us with 2 commands, the package and the deploy command. The first one puts all of your code artifacts into a zip file, uploads that to S3, and creates a package SAM template with the location of your code. And then the deploy command executes those changes in CloudFormation for your behalf. So let's use SAM and the SAM commands on our first demo. In this demo, we'll use the SAM template we've seen before to create a simple yet powerful calculator. It is simple because it only does one thing, and it does it well. It does addition. But it's powerful because it's entirely built using serverless technologies, which, among other things, means that you can have a single user using this calculator once, or you could have millions of users using the calculator millions of times, and it'll still work because with serverless, the scaling is done for you. Now, the way this application works is a user hits the API with a HTTP request with 2 query params. Those 2 query params are passed to the Lambda function written in Go. The function simply takes those query params, adds them up, and returns the result. Very simple. We'll do 3 things in this demo. We'll use SAM, the SAM commands, and the AWS CLI to create our serverless application. I'll be using the CLI because it's an easy way to show you what I'm doing, but you can, of course, automate all of this using your preferred tool of choice. We're then going to test our app and push changes to the Lambda code. And finally, because this is a talk that is about speed, but also about safety in deployments, I'll implement a security mechanism to prevent bad code from impacting all of our customers. Let me show you how this last point will work. Say we have a version 1 deployed using Lambda, and we are pointing all of our traffic to this first version. We deploy a new second version without pointing any traffic to it, and we're not changing the alias live that points all the traffic. We'll then run some validation to make sure that the function is actually adding the two numbers correctly. If it isn't, we're going to roll back and keep the alias pointing at version 1. This way, we have prevented bad code from affecting our customers. But if the validation says, yes, this calculator is adding, then we can fully promote the second version of the code by moving the live alias to the new version. So let's do this. Okay, so in the interest of time, I've done two things. I have pre-deployed my stack using the SAM commands, but don't worry, I'm going to be using the same commands in order to update the stack, and I'll show you. And I also have this here, all the commands that are going to be running, and the reason for this is it's just because it's easier to copy and paste. So let me show you a couple of the artifacts that I have. This is a SAM template that you've seen before. I think it's exactly the same one, or I may have added a function name, but it's the same one you saw on the slides before. And let's have a look at the code. So the code is written in Go. It's very simple code. It's just a simple calculator. So in the handler, what I'm doing is basically parsing those two query params and saving them in the left and right variables. Then I am defining the result as, remember that this should be adding. It is an adding calculator, but I'm making an intentional mistake, and this is just for the purpose of showing you how to update the code. And then I'm returning the result as part of the body of the API response. Okay, so let's test my application. So I'm going to be curling the endpoint with the query params 4 and 3. You can see that this calculator is not adding. Let's try other two, 4 and 4. Should be 8, not 16, so this is not adding. So what we're going to do is we're going to update our code. So we'll change that for addition. We'll save it, and after we've saved it, we're going to push that to the cloud. So we do that by first compiling the code, because this is Golang, needs compilation. And then I'm going to use the SAM package command, for which you need to pass the template name, the S3 bucket, and then the SAM deploy command, which simply executing all of those changes in your stack. In this case, the stack is called calculator add. Now, this change is going to take about 50 seconds. While it does that, I'll show you the security mechanisms that we were going to implement. So it turns out that canary releases for AWS Lambda are made very easy by SAM with an integration of code deploy. And this is the way you configure it. You have a deployment preference as a property of your Lambda function. That deployment preference gives you a couple of types. Actually, it gives you several types, and these are just two that I'm going to explain. This one points 10% of the traffic to your newly deployed code, and provided that within 5 minutes this CloudWatch alarm isn't triggered, then the canary is going to be completely promoted and receive 100% of the traffic. This second time is a little bit more conservative. It points 10% of the traffic to your canary, and provided that on the first minute, only 1 minute, the alarm is not triggered, then it's going to increase by 10% the traffic to the canary. So that configuration is going to take about 10 steps before your canary is fully promoted. Now, Code Deploy and SAM also give us a couple of toys we can play with, pre-traffic and post-traffic hooks, in order to integrate this into our existing CI/CD release process. Now, I was a bit cheeky, and I didn't show you initially all of my SAM template, but it turns out that I've included these 4 lines of code before to implement the safety mechanism we talked about. So I'm choosing an all-at-once deployment preference, which in itself is not secure at all. But what I'm doing is I am configuring a pre-traffic hook with a validator. So my validator is basically inspecting the code that I'm uploading to make sure that it's actually an adding calculator. So it sends some two query prompts, it checks that it's returning addition, and if it is, it allows to deploy the function all at once. So receiving 100% of the traffic. But if it isn't, it doesn't allow that. So it's a validator function, it's just a security mechanism. So let's see that at work in a second. For now, let's see what happened with my deployment. My deployment went successfully. Let's test it and see if my application is actually adding, which is what it's supposed to be doing. So I'm going to give it the query prompts 4 and 3. You can see a 7 comes back, 4 and 5. You can see a 9 comes back. So it is actually adding. So let's test the security mechanism by introducing another mistake. Let's change addition for something else. And let's push all of this to the cloud and see what happens. Now this deployment is going to take about 50 seconds, similar to before. So in the interest of time, we're going to go back to the slides and then we'll revisit this. Okay, so in summary of this first demo, you've seen how to get speed in software delivery by using serverless apps. You've seen how SAM makes it really easy to create, manage, and deploy serverless applications by allowing us to define with less code serverless applications, but also by simplifying the deployment process with a couple of commands. You've also seen how SAM's integration with Code Deploy gives us a that simple way to create automatic canary deployments and blue-green deployments so that we can get peace of mind when deploying Lambda, reducing the blast radius and automatically rolling back if our code doesn't work as expected. Now we can hit the deployment button without fear. But let's think for a moment about the process we went through. We wrote some code in Lambda, then we defined the application as code using SAM, then we deployed to the cloud using the SAM commands. But then we had to wait. We had to wait for about 50 seconds before the app was ready to go in the cloud. And only then, after waiting those 50 seconds, we were able to test it, get some feedback, and then go back to the authoring to fix or to keep iterating on our code. This flow is not great. If you're like me, builders are very intolerant to inefficiencies and interruptions when you're in the zone authoring, testing, and debugging code. So we're going to need a better flow. For example, something like this. Having a tight author, test, and debug loop in our machine and only checking code into our CI/CD process when we're ready to ship those features and that software to the cloud. This is great. There's no interruption, no waiting. It'll be much faster this way. Remember, we're getting speed. But doesn't Lambda run in the cloud? Well, in order to achieve this, we're going to have to bring the power of Lambda to our local laptops. And this is exactly where the SAM CLI comes in. This is the second tool we'll talk about today. And it is a tool for a CLI tool for local testing, debugging, and deploying of serverless applications. So there's no waiting, no interruption, and as an added bonus, you don't need internet in order to author, test, and debug Lambda functions. So we're getting more speed with SAM CLI. Now, the way SAM CLI works is by using a Docker image to mimic the Lambda's execution environment into our machine. It emulates things like the Lambda timeouts, memory limits, and runtimes. Now, here are some of the things that you can do with the SAM CLI. I'm not going to go into the detail of all this because we're actually I'm going to show you in the second demo. But the important thing is now you can test your Lambda function in a couple different ways in your machine. The SAM CLI is a game changer. It means you can quickly iterate over your functions with hot reloading, and you never have to wait, getting speed in your serverless projects when you're authoring and releasing of the software. It also means that, as an added bonus, that you don't need internet connectivity to author, test, and debug serverless applications. So next time you're flying, you can use the serenity of most flights, provided they're not crying babies, in order to launch SAM CLI, get in the zone, and start coding. So let's go for our second and last demo. We learned that our customers didn't want to add, they want to multiply. Who would have thought that? So what we're going to do is, without internet, we'll author a Lambda function in Node.js with multiply functionality, very similar to the one we had before. We'll test it and debug it locally with the SAM CLI before we deploy it side by side to our existing application. The reason we're deploying it side by side is because I want to show you another way of implementing safe deployments for serverless applications. This time, we're going to be using for safety canary releases for API Gateway. It's a feature that allows you to gradually roll out new APIs and new API configurations in Amazon API Gateway. We'll create a new stage configuration that points to our new Lambda function and point a small percentage of traffic to it. If we are happy with the outcome of that small percentage of traffic, we'll promote that API stage configuration to receive 100% of the traffic. So let's do this. So let's check my previous deployment before we start with demo 2. First off, we can see that the deployment failed, and that's a good sign. Remember that we try to trigger the security mechanism. So let's curl the endpoint and see if my calculator is still adding. Yes, it is still adding. One more thing that we can do to prove that my safety mechanism works is using this to try to find rollback events in our CloudFormation events. And we can see that there's actually a rollback event that was started by code deploy. So we're good. The security mechanism works. So let's go to our second demo. In our second demo, we have all these artifacts. I'll show you a few. This one, for example, is the SAM template for the multiplying function that we're going to deploy. It's actually simpler than the one we used in the previous demo because remember, we're not deploying a new API gateway here. We're going to be using the one before where they're just deploying the Lambda function side by side. And the code, we could argue all day about this, but I believe JavaScript is much simpler than Go, but it's actually doing the same. So it's just taking those two query params into the variables left and right, and then defining the result as the addition, and then returning that as a string as part of the result of the body. Now remember that this function should be multiplying. It's what our customers wanted, but I'm making an intentional mistake again to show you how to update this using the SAM CLI. Okay, so let's start testing SAM. SAM is a CLI tool. The first thing I can show you is the version that I have installed on my machine. In this case, a newly released 0.3.0. Something else we can do is we can validate our template, and this is a best practice. You should validate your templates in your machine and as part of the CI/CD process again, the same way you would with CloudFormation. So you can see that it gives us a couple of warnings and it's telling us that our template is valid. So let's test our Lambda function in one way that SAM allows us to do. And what we're going to do here is SAM locals.api. What this is doing is basically creating a proxy in my machine using Docker that allows you to test our Lambda function in response to HTTP request. So what I can do is I can use that, go to my browser. I'll zoom this up a little bit. And I'm passing the query params 4 and 2. And as you can see, it's returning the addition. And we don't want addition, we want multiplication. So let's fix that. I'm going to go back to my code. In my code, I'm going to fix this for multiplication, which is what it's supposed to do. I save it, and I can immediately swipe back to where I was, refresh the browser, and it's going to be immediately using the new version of my Lambda code. You can see now the result is 8. This is big. It means you can quickly iterate over your functions with hot reloading so you don't have to wait. How cool was that? Now, as part of that command that I show you, you can see that you're also receiving the Lambda logs in your laptop. Even if, without using internet, you're receiving what normally you find in CloudWatch logs. And this is great if you need to troubleshoot or debug your code. Okay, so that was the SAM local start API. Let's, because I'm happy with that, I'm gonna quickly deploy it to the cloud, and then I'll keep showing you all the good things about the SAM CLI. So let's deploy it using SAM package and SAM deploy. I don't need to compile anymore because we're using Node.js. And that's gonna take about 50 seconds again. So for now, I'll just interrupt this. Should have gone through. And I'll show you the other thing. So we can test our Lambda function in a second way using the SAM local invoke command. But in order to do that, we need to pass it the event source that Lambda needs in order to execute. Well, the SAM CLI also allows you to generate that event source using this command. So I'm generating an API event. You can also generate S3, DynamoDB, and Kinesis events. It's going to be a method get on the main resource, and I'm going to give it the two query params 4 and 2. It generates a JSON payload that if you saved it the way that I did here in my request JSON, then you can use that SAM local invoke command in order to execute execute Lambda on my machine. This is going to take a second or two, and it's here. So you get the logs in the same way we did before, and you get the result. The multiplication of 2 and 4 is 8. So my Lambda function is working fine. One more thing that I'll show you about the SAM CLI is you can debug. You can do live debugging on your functions. Using the same command, SAM local invoke, you can pass it a debugger option and a port. And what I've done is I pre-configured my IDE to listen on this port 5858. So I am going to have a breakpoint here. Then we can go to my debugger, start the debugger. And you are debugging your code in the same way you would any non-serverless code. So you see that here I have my variables 2 and 4. You can step over the line of code. Then you can see the result is 8. The same way you would any non-serverless code. That's great. Okay, so let's go back to our deployment. So hopefully our multiplication function was deployed correctly. And you can see that yes, I actually grabbed the ARN of my function. So what we're going to do now is we're going to do canary releases for API Gateway. So at the moment we have our application completely separate to this function. So we need to tell that API Gateway about this new function. And we need to tell this new function about the existing API Gateway. So I'm going to do that with two CLI commands that I want you to memorize. No, I'm joking. You shouldn't memorize this. But it's basically the API put integration command and the Lambda add permission command. This is going to allow them to know about each other. So you run those commands. Now they know about each other. And what you finally need to do is to create that canary deployment. You do it with the AWS API Gateway create deployment. So this is going to create another stage of your API Gateway, and I'm going to point 20% of the traffic to that second stage that it's going to be using my new Lambda function. So let me just step here for a second. I'm going to be pointing, I am pointing 80% of the traffic to my addition calculator and 20% of the traffic to my multiplication calculator. So let's test that. Hopefully, about 1/5 of the time, this function is going to be multiplying. So if I give the query params 4 and 3, it is adding, adding, adding. Don't worry, we have all day for this. Adding, and there you go. Actually, exactly 1/5 of the time. Let me do one more, and then you go 7. So about 20% of the traffic is actually multiplying. If we are happy with the results of our canary release, we can promote that canary with this last command. And I promise you, this is the last command I'll be running today. So I'm basically copying the canary configuration into the deployment configuration so that 100% of the traffic goes to the multiplication function. And after I've done that, I can test it and verify that 100% of the traffic goes to the multiplication function using the same API that we had before. So there you go, multiplication, multiplication, multiplication. Now you have seen how easy it is to create canary releases for API Gateway. So let's go back to the slides. In this second demo, we saw many things. We saw all the things that you can achieve with the SAM CLI, how the SAM CLI takes all the good parts of SAM and AWS Lambda and brings them to your local machine, allowing you to have a tight loop when you're authoring, testing, and debugging serverless code. It's giving us speed in software creation for serverless apps by allowing us to build serverless applications with no waiting, no interruption, and even without internet connectivity. We also saw in this second demo how easily it is to enable safe deployments for API Gateway by using canary releases, the canary releases feature. This way, we gradually roll it out new API configurations, but you can also roll out new APIs entirely. You have the ability of rolling back if our changes don't work as intended. And although I made this all manually in our demo, you can automate it using the same commands that I use. So to finish, how can you get started? There are a lot of options, from free online on-demand training to examples on the SAM and the CLI repos that you find on GitHub, a tutorial for your first serverless web application you can find on the AWS website, blueprints you can find on the Lambda console and also on the AWS serverless application repository. But also there are two services, AWS CodeStar and Cloud9, that make it really easy to get started with serverless. With CodeStar, you just make a couple of choices in the console, and in 5 minutes, it gets you started with a full CI/CD pipeline and a fully working application, and if you want, a Cloud IDE as well. Now, Cloud9 is the Cloud IDE that comes pre-packaged with all the tools that you need. It allows you to write, run, and debug code with just a browser, and it provides a seamless experience for developing serverless applications. So tomorrow, when you're sitting in front of your IDE about to write a new app or feature, I want to challenge you to deliver it faster by making it serverless, but also deliver it safely by implementing canary releases. Finally, please remember to bring your laptop next time you go skydiving, because now you can build anything serverless, anytime, anywhere. To gain more confidence and hands-on experience with AWS, access our digital training, which is built by AWS experts. Attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And then you can validate your technical expertise with AWS and use practice exams to help you prepare for an AWS certification. AWS has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. Learn more about the APN partners and find the right APN partner for your needs by visiting the AWS APN booth at our showcase. Thank you for attending the session. I hope that you have learned something and that you're going back to your desks feeling empowered to go out and build something great. Thank you.